Hello again, I am back. So today we will discuss Lewis structures. We will talk about how to draw the Lewis structures, which rules we have to follow. Okay, let's now continue. So actually a Lewis structure is also called a dot structure, and it is necessary in order to show the electrons arrangement or the number of bonds in the molecule. We can show electrons as dots. Every dot is one electron, or we can draw them like lines. One line will refer to two electrons. It means one bonding. Two electrons create one bonding. Okay, how to draw these structures? Which rules do we have to follow? Let's consider. We see that first of all we have to determine if the compound is molecular or ionic. Actually, in this video we will consider only molecular compounds, not ionic. Further, I will tell you also about ionic compounds. Today we will discuss only molecular compounds. The second one, we have to count the number of valence electrons of each element. So we just summarize the valence electrons, the numbers of valence electrons of each of the elements, and find the overall number of valence electrons or pairs. If we have 16 electrons, it will be like 8 pairs. When we find it, after that we draw the skeleton of our molecule, and then we complete the skeleton. And for completing the skeleton, we need to take into consideration the octet rule and valence of the elements. They should be correct and followed. And at the very end, we need to check formal charges. Let's take examples and see how it is done. So, first example, let's take carbon dioxide. Let's draw the Lewis structure for carbon dioxide. So, first we determine whether it's a molecular or an ionic compound. So, this one is a molecular compound. Let's count the number of valence electrons. So, valence electrons of carbon. Let's have a look at the periodic table. We see that carbon is situated in the fourth group. Oxygen is situated in the sixth group. Main group. So carbon will have 4 valence electrons, oxygen will have 6 valence electrons. Let's summarize them. 4 electrons for carbon plus 6 times 2, because there are 2 oxygen atoms in this molecule. Each of them has 6 valence electrons. So when we multiply 6 by 2, we summarize it with 4, we get 16 electrons or 8 pairs. And now let's draw the skeleton. Well, we can arrange it in this way: 1 carbon, 2 oxygens, or we can put oxygen in the middle. Let's now understand which of them is correct. We need to figure out the arrangement. The second one will be better because it might seem difficult with complicated molecules, with big molecules. It might seem difficult where and what to put. In this case, we know that we imagine that the atom which can create more bondings will be in the middle. It's just a hint, like a life hack to do it. Carbon will create 4 bondings, oxygen will create only 2 bondings, so carbon will create more bonding than oxygen. Let's put it in the middle. So this structure is correct. We put it, we draw the skeleton, and now let's complete our skeleton considering the valence of elements and octet rule. So these are 2 bondings. We said that every bonding is 2 electrons, like it's 1 pair. If we draw it with like a dot structure, instead of lines we draw dots, so electrons, it will look like this. And now we can see that around carbon there are 4 electrons. According to the octet rule, there should be 8 electrons. So let's add 4 more electrons around carbon. So when we add it, we add 4 more electrons, like 2 pairs for carbon. From each side we add 1 more pair. And Now we see that there are 8 electrons around the carbon. 8 electrons correspond to 4 bondings, and valence of carbon is 4. We see it's correct, everything is good, because valence of carbon is 4 and there are 4 bondings, and there are 8 electrons around it, so both octet rule and valence of the element are considered. About oxygens, we see that now around each oxygens there are 4 electrons, and 4 electrons means 2 bondings. Valence of oxygen is 2. Well, oxygen is bivalent, it is balanced 2, so valence is followed here, but we see that there are only 4 electrons. Octet rule is not considered. We cannot add additional valences, additional bondings here, but we can add missing pairs like free electrons around the oxygen. If each of the oxygen takes 2 pairs of electrons, so overall 4 electrons, both valency and octet rule will be followed. Now look at this picture. We see that around the carbon we have 8 electrons and valence is 4. Around each of the oxygens we have 8 electrons and valence is 2. So now everything is correct. And as I said, instead of this structure, the dot structure, we can draw the pair structure. We can draw lines instead of electrons. 2 electrons correspond to 1 line. We can draw it in this way. And we can count now these red lines. These are pairs. We see that there are overall 8 pairs, or we say 16 electrons. When we did the calculations at the beginning, when we calculated valence electrons, we saw that we should obtain actually 16 electrons. And we got it. We got 16 electrons. So our structure is correct. And the last one is checking formal charge. We need to check formal charge. Let's see. Let's just figure out how formal charge is checked. In order to calculate the formal charge, by the way, we do it separately for every element. We take number of valence electrons of this element minus number of free electrons around this element and minus number of bonds around it. Let's review. If we are talking about carbon, the formal charge of carbon will be number of valence electrons of carbon is 4 minus number of free electrons that are around carbon, mean not bonded electrons. We see there are no free electrons, so it's 0 minus number of bonds is 4. So using this formula we get formal charge for carbon 0. Great. Then let's calculate the formal charge for oxygen atoms. Actually, we calculate separately for every oxygen atoms. Since these 2 oxygen atoms are analogical, they're similar, we can calculate it only once, and then we can apply it for both of them. So for oxygen, we said that number of valence electrons of the oxygen is 6 minus number of free electrons around each of the oxygen. We have 4 free electrons, so minus 4, and 2 pairs, 2 bondings, so minus 2, overall 0. So formal charges are 0, and that's good. If the formal charges are number of them is few, we don't have a lot of formal charge, this molecule is stable. The less, the better. So when formal charges are all 0, that's good. And now let's draw the Lewis structure for NO, nitrogen monoxide. Let's draw it and see how it works. So as we see, there are two possibilities. Let's draw each of them. And let's now define which of them is more stable, because only one of them is more correct. Let's now calculate the formal charge for each of them. Here, formal charge for nitrogen will be, as we say, number of valence electrons, it's 5, minus number of free electrons around it. We see that there are 2 here and 1 here, overall 3, minus number of bondings, 2. We get 0. So formal charge of nitrogen is 0 in this case. Let's calculate the formal charge of oxygen. Number of valence electrons, 6, minus number of free electrons, we see 1, 2 pairs, it means 4 electrons, minus number of bondings, 2, that will be 0. So in both the cases, formal charge are 0. Let's now move to the second one, to the second molecule. Here, formal charge for nitrogen will be, so we take 5, number of valence electrons, minus number of free electrons, in this case will be 2 pairs, so it's 4 electrons, minus number of bonds, 2. And we see here it appears to be -1. Let's now calculate the formal charge for oxygen. Formal charge for oxygen will be number of valence electrons, 6, minus number of free electrons, we see 1, 2 and 3. We have 3 free electrons, minus number of bonds, 2. It will be +1. Okay, so as we can see, for nitrogen formal charge will be -1. For oxygen it will be +1. So first of all, we see that in the first molecule formal charges are 0. If the formal charges are minimum, it's good. It means that the molecule is stable. If there are a lot of formal charges, molecule is not stable. So among these two molecules, the first one is more stable because there are less formal charge. We should try to draw such a structure when the formal charge is minimum, because this molecule will be more stable. Moreover, let's have a look. We see that nitrogen has a negative formal charge. Oxygen has a positive formal charge. It's impossible because oxygen is more electronegative. It cannot be positive while nitrogen is negative. It should be opposite. Take it also into consideration. For this reason, when you start drawing free pairs, we start drawing them on oxygen. First draw them on oxygen. Then we count that we have overall 4, but should be 5. And then if what is missing is added to the nitrogen. It's not opposite. First of all, we give electrons to the electronegative molecule. So this molecule, where the lone electron is on the nitrogen, is correct. So this is how it works.